Hello there. In this video, we're going to review notation. Now, notation is something that you have worked with before in your science classes when you do scientific notation. So we're going to learn about three types of notation. Scientific notation, which is something you've done in the past. We're going to also learn about engineering notation, which is something that's going to be new to you, I think, unless you've taken another class about engineering notation. And lastly, we're going to do the International Standard or SI prefix notation. Okay, so those are the three notation that this course or this little lesson is going to cover. Before we start with any scientific, engineering, or SI prefix notation, I would like to do a small review so that we know or you understand what it's like when you write any number and you say times 10 to the exponent of like 6, or when you say a number times 10 to the negative 4, or whatever number that you're saying. Okay, let's first make sure we understand what does it mean when I say times 10 to the 6, for example. So what that means is that you're taking whatever number, let's say the number 5 for both of them. You're taking the number 5 and you're saying that is 5 times 10 to the 6th power. That means times 10 6 times. So 2, 3, 4, 5, and 6. So that's 1, 2, 3, 4, 5, 6. So that is 5 times 10 6 times. Well, whenever you take the number 5 and multiply by 10, it means that you add, so the decimal point is right there, and when you multiply by 10, you add a 0, or you move the decimal to make the number larger. So that would be times 10 one time, 2, 3, 4, 5, and 6. So some people call that moving the decimal 6 times. I'm going to be careful not to say to the right or to the left because it depends if you're going from the notation to the whole number, the long way of saying numbers, or backwards. So I just know that if I multiply a number by 10 6 times, that number is going to be a very large number, right? So now let's do this. Let's talk about what it means when I do, let me use a different color. Let's say 5 times 10 to the negative 4. For 5 times 10 to the negative 4. What does that mean? Well, when I use, that would be 5. But what it means is when you have a negative on the exponent, when you have like any variable like y to the negative 4, that's the same thing as saying 1 over y to the 4th. So whenever you have a negative exponent, that just means that you are dividing by that number that many times rather than multiplying, because a negative exponent just means that the number is in the denominator. And if you move it back down to the denominator like I did here, then that means that the exponent becomes positive. So what you're saying here when you have times 10 to the negative 4th power is that you are really dividing. So I don't know how you would like to write it. I'm going to actually put times 1 over 10 times 1 over 10 times 1 over 10. That's dividing by 10. 1, 2, 3, 4 times, right? So that's what you're doing. So whenever you see a negative exponent, what you have is you're dividing by 10 that many times. Now, to do that, again, the decimal is always on the right-hand side of a whole number, like that's like a standard knowledge. And when you divide by 10, the number gets smaller by a magnitude of 1. So if I divide by 10 one time, it would be 0.5. If I divide by 10 one more time, that would become 0.05. And so on and so forth. So if I divide by 10 4 times, it would be 1, 2, 3, 4, and the decimal would end right there. So it moved 4 spaces to make the number smaller. So again, if I multiply times 10 to a negative exponent, my original number, which was 5, is going to be divided by 10 4 times, so I get my answer, which is a very small number. 5 divided by 10 4 times is 0.0005. Okay, so that was just a recap. Again, if you have a positive exponent, that means you're multiplying by 10 that many times. That means making the number larger, or moving the decimal to the right if you would. But again, I'm going to try to not do that. And then if you divide, as you're down here, if you divide by, or if you multiply times 10 to the negative exponent, you're dividing the number and making the number smaller. Okay, so that's something to make note of. So we need to know that, because as you can imagine, scientific, engineering, and SI prefix notation are going to use this concept where you have to either multiply by 10 several times or divide by 10 several times. Okay, I'm going to erase this part now. Hopefully you're taking notes in your engineering notebook. Okay, so now let's talk about scientific notation. So the scientific notation format is any number. I'm going to call the number A. It can be any number, decimal as well, multiplied by 10 to any integer b. So A has to be a number that is, oh, I just accidentally deleted my page. There you go. So A has to be any number that is less than 10. So it cannot be 10. It can be 9.99999, etc. But it has to be greater than or equal to 1. So it cannot be 0.999. So it has to be 1 or above 1, but it cannot be 10. So that's why I put less than. There's no equal sign on the A less than 10. And B is an integer, meaning it's positive or negative whole number. So for example, if I say I wanted to write the number 500, let's say 500 amps, in scientific notation, that would be 5 times 10 2 times, right? We would have to move the decimal twice to be able to get a number that is between 1 and 10, and then so that would be 5 times 10 to the 2 amps, right? I think that should be a review from your other classes. Also, if I give you a number, that's a number that has many zeros, a very large number, I could also do 0.000072. So I have to move the decimal as many times until I get a number between 1 or equal to 1 and less than 10. So if I move the number 1, 2, 3, 4, 0.7 is not greater than 1, so I have to move it one more time. So the decimal would end right there, and it would be 7.2. 7.2. And how many times did I have to multiply or divide by 10 to get to the original number? So 7.2, if I put a positive exponent, it would be a very large number, and this is a very small number, so I have to divide by 10, 1, 2, 3, 4, 5 times. So, oh, my number's not working well with me. There you go. 5 times right there. So there you have it. So whenever you have a number with many zeros before it, a very small number, like this one, this is a very small number, you have to take an original number between 1 and 10, and you have to divide by 10. If you have a large number, and you have to take the number and multiply by 10 to get the original number. So that's a review of scientific notation. Well, engineering notation is very similar, except engineering notation is more like the same way that we deal with money. So here, I'm going to erase this so that I can now tell you about engineering notation. So engineering notation, what it is like money. So if you have, let's say, 1,000, 1 million, 1 billion, 1 trillion, you just move the decimal to where there's a comma, And that is so that we only deal with thousands or thousandths, right? So, for example, engineering notation, the format is still A times 10 to the B. The only difference is, well, the difference, not only there's two differences. A, oh, let me put it in a, has to be greater than or equal to 1, which that's the same. It has to be a number that is more than 1, but it has to be less than 1,000. Okay, not just 10. Because we're going to move the decimal to wherever there's a comma. So we just look for a number between 1 and 1,000, not 1,000, but less than 1,000. And B is an integer because we're going to be moving it only in groups of 3. So it's an integer multiple of 3. For example, if I give you the number 9400, so 9,400 volts, right? So what I do is, oh, that's not a good example because it's going to be the same as scientific. Let me add one more zero there. So 94,000 volts. Okay, so what I would do is I would start from here where the decimal is and move it in groups of 3. So I move it 1, 2, 3 to right there and check if the number is between 1 and 1,000. And it is. 94 is between 1 and 1,000. So that becomes 94 times 10 3 times. That's how I put that correctly in engineering notation. Now, if I was doing it in scientific notation, I'll do it in red. This is wrong. If you're doing it in scientific notation, your first instinct would be 9.4 times 10 4 times. But if I do that, notice that my exponent is not a multiple of 3. So that would be wrong. So I would not do that. Okay, let's try another example. So another example of engineering notation, let's say we have this number, 12 and a bunch of zeros. I'm going to add commas just so that we don't lose our place. So there you go. I put commas. So actually the commas make it super simple because I can just jump in groups of 3, so I will jump to where the comma is. So this is my decimal right there. I jump it 1, 2, 3. If I put the decimal there, is that number between 1 and 1,000? The answer is no, so we have to keep going. So we move it 4, 5, 6 times. Is that number between 1 and 1,000? That would be the 120. The answer is yes, it is between 1 and 1,000. So that's where we stop. So our number would be 120 times 10. How many times did I have to move the decimal? 1, 2, 3, 4, 5, 6 times 10, 6 times. There you have it. So that's how you deal with large numbers. Let's say now you have a small number. So I have 0.0000000. Let's see, 2, 5, 9. I don't know. I'm just making it up. Now it's kind of weird to put commas, but that helps you also because it's going to make you figure out where you're going to stop. So I know it's kind of weird to put commas going to a small number, but again, it's just for visual purposes. So the zeros right there, we're going to have to move the decimal in groups of 3. 1, 2, 3. If I put the decimal at this point, it would be point all these numbers, and that is not more than 1. So we have to keep going. 4, 5, 6. If my decimal's there, point something, that is still not over the 1, so I have to keep going. 3 more, so 7, 8, 9. If I put my decimal at this point, now it would be 25.9, and that is a number more than 1, less than 1,000. 25.9 times 10, well, I have to divide 25.9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9, that means I take 25.9 and divide by 10 9 times to get my original number. There are some cases, like if I give you this number, let's say that number, right? If I want to put it in engineering notation, you notice that I move my decimal 3 times. I'm going to put a comma there just to make it easier. So I moved my decimal 3 times, which is 1, 2, 3, and I stopped there. That's 0.3. That is still not bigger than 1. But I can't move it, can I? Well, I want to remind you that even though it's not shown here, there are non-significant zeros. I guess you could go to infinity. I'm not going to do that many. But there are non-significant zeros that are just not part of our number. So I'm just going to add the 2 that I need, because if I move my space, my decimal 3 more times, would be 4, 5, 6. If I put the decimal here, that would be 300. So that would be 300 times 10, 1, 2, 3, 4, 5, 6 times, or -6, because it's a very small number. So whenever you have a number that ends and it doesn't have any more spaces to move in groups of 3, just add non-significant zeros because they are there. Yeah. So that is engineering notation for you. No matter what number you have, just move the decimal in groups of 3, and as long as the number is between 1 and 1,000, the number is correct. The only trick is, like, if I give you a number 40, how do I write that in engineering notation? Well, it's already between 1 and 1,000, so that is the answer. If you wanted to be super picky, that would be 40 times 10 to the 0 power, because 0 is a multiple of 3. So that would be the correct engineering notation, 40 times 10 to the 0, because at 10 to the 0, any number to the 0 power is 1, so it's just 40 times 1. So that is engineering notation. Okay, I hope you were also taking notes. You can always review this video as many times as you need it. Now we're going to move on to SI prefix notation. Okay, so SI prefix notation is the last notation that we're supposed to cover right here. SI prefix notation is just one more little step after engineering notation. So what we're going to do is SI prefix notation. I'm going to move over here to the left so that I can actually use these numbers as example. So it's the Système International des Unités, the International System of Units, SI prefix. So for the SI prefix notation, what you need to know is that whenever I have a number such as this one on the left, 120 times 10 to the 6th power, instead of saying times 10 to the 6th power, I can just say 120 mega, whatever units we're talking about. Instead of saying times 10 to the -9, I would say nano. Instead of saying times 10 to the -6, I would say micro. And this one I wouldn't say anything because it's the base unit. So what we're doing in SI prefix notation is being super efficient by not having to even write the number times 10 to the exponent. We just use a letter as a prefix that means the number. So let me give you a list of all the prefixes that we will be using in this class. So let me start in the middle and go up and then down. So if a number, like, I'll just use the number 1. So the number 1, if it's just a 1, that's just my base, which is no prefix. Okay, it's just 1. Like, let's say we're talking about volts. It's 1 volt, and that's it. If I go, because it's just like engineering, we're only dealing with multiples of exponents of 3, multiples of 1,000. The next number above that would be 1,000. So, excuse me, we know that times 1,000, that's the same thing as saying times 10 to the 3rd, and we say kilo, or just the letter K. Okay, if we have 1,000,000, or 3 more zeros, that would be times 10 to the 6th, and we say mega, or we just write the capital letter M. If we have 9 zeros, oh, I don't know if I'm going to be able to fit it. Maybe I'll just put the times 10 to the 9 here. That would be giga, or just capital G. And it keeps going up as I guess as many as you can. But again, we only use so it's kilo, mega, giga. Oh, I know the next one. Do you guys know it? Times 10 to the 12th. I'm not going to write it. Well, I guess I should. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So that would be tera, or capital T. Nowadays, you can buy terabytes of hard drives so that you can store your memory. Okay, store your data in memory. Now that's going positive exponents. If I want to talk about very small numbers, I just do 0.001, which is the same thing as saying times 10 to the -3, and we say milli, or little lowercase m. Okay, be careful if you write your m's. like capital like this, that's not going to work out. You need to write them like a capital letter, like sharp pointy things. Okay, now if I say 0.00 and then 001, that's times 10 to the negative 6. We say micro, and we use the lowercase u or the Greek letter mu, like that. Both of them are correct. Okay. Then if we do 9001, which is times 10 to the negative 9, we say nano or lowercase n. If we do 0.0001231230001 times 10 to the negative 12, we say, I always forget this one. Yeah, it's pico. Yeah, it's pico or lowercase p. That sometimes they make it a little curvy, like an italic letter p. And then the last one, 123, 123, 123, 123, and times 10 to the negative 15. That's femto, like 15 femto, and that's the little curvy lowercase f. Kilo, mega, giga, tera. I think if you want to know the times 10 to the positive 15, I think that's peta or capital P. So there you go. It's handy to have these prefixes, and you always have these prefixes in whatever note sheet you're doing. So let's say I want to tell you, I give you this number. This number, that many volts. I want you to put it in the proper SI prefix notation. Well, you can see here that you first have to do it in engineering notation. So you move the decimal in groups of 3. 1, 2, 3, that number is not between 1 and 1,000. 4, 5, 6, that number is between 1 and 1,000. So that's 45 times 10 to the 6th power volts. But that's engineering notation. I want SI prefix notation. So what I'm going to do is I'm going to take that prefix and rewrite it with the letter that's a prefix. So we say 45, and we can see that times 10 to the 6 is mega volts. And I don't actually spell it, I just put the capital letter M. So that's how you do SI prefix notation. If I have a very small number, 0.000, and again, these commas, I know they're weird, but they're going to help you see the numbers faster, where to move the decimal to. So that number, I have to first do it to engineering notation, 1, 2, 3. That number is not between 1 and 1,000. 4, 5, 6. That number is not between 1 and 1,000. 7, 8, 9. That number is between 1 and 1,000. So that's 4.5 times 10, and we moved it 9 times to make the number very small. And so there you go. Oh, I didn't put a unit. Let's say this is amps. So, excuse me. So now what we're going to do is we're going to replace that prefix with 4.5 times 10 to the negative 9 is nano amps. There you have it. And so that's how you do SI prefix notation. You first put it in engineering notation, and then you jump over to SI prefix notation. Now, eventually, you will get a little bit faster at this. Let me make a number line at the bottom. And so you'll realize that if you imagine the entire sequence of numbers, if you have a number that is anywhere in these groups of 3, you'll see that you'll know the prefix right away. So, for example, if you have a number in this first 3, you know that it's going to be in the, oh, I want a different color. Let me make it red. Yeah, it's going to be in the milli. If you have it in the next group of 3, it's going to be in the micro. The next one is going to be in the nano, and then the pico, and it keeps going to femto. If you have it in these first 3, there's going to be no unit because it's just between 1 and 1,000 already. If you have it in the next, it would be kilo, mega, giga, tera, etc. So if I give you a number, let's say a number that's 0.0007, you know that the number is going to start here in the micros. So you just have to fill in. So oh, I need to move my decimal 3 times, but it's not going to be big enough. So that's going to be 700 micro units, whatever unit you're talking about. If I give you another number over here on the right, or I'll do another one on the right hand side. If I give you a number like 000, 000, 000, 49, you know that the number is going to be, it starts in the nano, so the number is going to be 4.9 nano, because I'm going to move my decimal until I get to there. This is a little shortcut. If this is fine, if you find this part a little difficult, it's understandable. After you practice a little bit, you'll be faster at it. Last example on the left, if I give you a number like I did earlier, 4, 5, and then it has this many zeros, you know that the number starts in the mega, so this would be 45 mega units. If I had moved it to add more zeros, like 7, 3, 1, this number would be, starts in the giga, so it's 1.37 giga whatever units, because that's where it starts. Lastly, sometimes you'll have to translate between one and the other. So let's say I have 7 kilo ohms, and I want to put it for some reason in mega ohms. I don't think that this will have to ever happen because 7 kilo ohms is already the proper notation, but sometimes you have to translate from one unit to another. So what I want to emphasize to do this, it's actually quite simple. What's the difference between kilo and mega? So kilo and mega, the difference, let me scroll up to this thing. So the difference between kilo and mega is moving the decimal 3 times, right? So all I have to do is figure out, okay, I have to move the decimal 3 times. Do I make the number larger or do I make the number smaller? So think about pennies and dollar bills. So if I give you $1 in pennies, a smaller unit, you're going to have a larger quantity. You're going to have more pennies because it's a smaller unit than if I give you dollar bills, right? You're going to have $1 bill, a larger unit. You're going to have fewer of them than a smaller unit. A smaller unit, you will have a lot more quantity. So kilo, in this case, is a smaller unit compared to mega. So this is like my pennies, and this is a large unit. Okay, so what's going to happen is you're going to have more small units than large units. So what you're going to have to do, we know that we're going to have to move the decimal to, from kilo to mega is 3 zeros, so a magnitude of 3 times 10, 3 times. But do I move it to the right or do I move it to the left? Well, small units, I'm going to have more. Large unit, I'm going to have less. So I'm going to have, to make it less, I'm going to have to move the decimal to the left, or to make the number smaller. Let's try another one in case that was not so clear. Let's say I give you milli, so I'm going to give you milli, so let's say I give you 25 milliamps, and I want to know what is that number in nanoamps. So here, my milli and my nano are my units. The difference between milli and nano is 6 zeros, or times 10, 6 times. So I'm going to have to move the decimal 6 times. So do I move it to make the number larger or to make the number smaller? Well, the milli is a large unit and the nano is the small unit. So you're going to have more small units. So the number has to get larger. So it's 25, and you're going to have to move the decimal to make more of a small unit, and we know it's 6 times, 1, 2, 3, 4, 5, 6, and so we get rid of that decimal right there, and the decimal went to the right 6 times because now the number is larger. Again, this is like more pennies than dollars. So there you have it. If you're gonna go from one unit to another, just figure out how many times do you have to move the decimal, and then just compare it. If you're going from a larger unit to a smaller unit, you're going to have more small units. If you're going from a smaller unit to a larger unit, you're going to have fewer of the large units. So there you have it, folks. That was the lesson on scientific, engineering, and SI prefix notation. I hope that was clear, and thank you for watching.